This is Jacob Kumpon from Claw Industries, and once you estimate your project using the calculator, you're going to have a unit cost summary that looks like this. The numbers in red are estimations based on your specific location, but are extremely variable depending on your local market. And this wide range is a problem for determining the unit cost of producing a glass SCM. To solve this, we complete a research project to determine what the actual costs are at your proposed facility in your market. This project has 3 parts that we will discuss in this video: a market assessment of glass in your area, a disposal cost assessment for the inbound glass to the facility, and an electrical analysis to determine your electric cost per ton. In the end, you will have a verified unit cost, secured suppliers of MRF glass for your facility, and a total project cost, allowing you to determine if producing glass SCMs is the right fit for you. The first phase is a market report and is the most important part of the project. And since we're paid to take this material, we need to determine how much we could charge and where this material is physically located in the market. We do this by finding all locations in your area that generate glass, and then get in touch with these facilities using our connections in the industry. By studying local disposal costs, we can determine what the recycler's current outlets are and what we can charge, allowing us to propose pricing and get them signed on as a supplier. This allows us to complete a market assessment and determine the best recyclers in the area to supply the proposed facility. In our operation, we avoid MRF glass contracts and typically find that it's better to play the market. Once a year, we go through and do another assessment to determine if we could raise our prices to the recyclers in the year ahead.
This is an example of the market summary, and we start with recyclers in the local market. These are the best facilities that we're able to find in your area. We have the facility name as well as the contact information for the people that work at these plants. We then have the ownership structure and their stated contamination level of this material, as well as the annual tonnage that they produce. And that leads us to our immediately available tonnage in the local market. What's highlighted in green here are the best facilities that we're able to find to support the operation. These are going to be the plants that we focus on as we continue through the research project. Next, we have the logistics situation facing each one of these recyclers. So we can see the same facility names here and the end market of where their glass is actually going, followed by what they pay to get rid of this material, and the distance that the material is traveling to the final destination, as well as who's responsible for actually transporting this material. Typically, the recycler is responsible for paying the logistics for getting rid of the glass, and they typically do this with third parties, which adds a lot to their actual disposal cost of getting rid of MRF glass. We then have the agreed MRF glass payment. So we start to negotiate and get them to agree to a price to send it to the proposed facility, the distance, as well as who's going to provide the logistics in this scenario. We highly recommend bringing this logistics internally and doing it yourself. It's a way to save a lot of money on MRF glass transportation rather than going to the third party. And then we have the end market summary down here of all the end markets in your area of where this glass is ending up currently. Next, we have our alternative glass sources, and this is a list of all the facilities we found in the market that we weren't able to get great data from, but that we know that they generate glass. And so we use this as a roadmap once the facility is operational to continue to search for better glass pricing. And finally, we have our landfill list, which is a summary of all the landfills available in your market, where they're located, the tipping fee at these facilities, as well as the distance from the proposed operation. The big thing to note here is that if you're located in a county that has a county-run landfill or a municipal landfill, you're going to see some really great tipping fees for disposal costs. It's really going to help out your unit cost.
Once we've identified our top recyclers, we need to understand the disposal costs we're going to face when using their material. MRF glass is extremely variable and changes facility to facility, depending on the type of equipment that they're running. MRF glass is made of 5 primary components: glass we can utilize, ferrous metal, non-ferrous metal, paper and fluff. This is really anything that can be blown out with air, and plastics and lightweights. Understanding the exact composition of in-feed MRF glass is extremely important, as disposal costs can quickly become one of the largest unit cost line items for the facility. We developed a test method to determine the composition of MRF glass in a reliable way so that we can compare facilities. We start off with 2 5-gallon bucket samples from the supplier, and from there we take a unit mass to determine the material's bulk density. Next, we complete a full manual sort of the sample. This is the most reliable way to determine MRF glass composition, and it allows us to break the sample into our 5 main categories. When utilizing MRF glass for concrete, a more robust washing process with water is needed to avoid air entrainment problems. This water soaks into our waste materials and significantly increases their weight and thus the disposal costs. We soak our paper and plastic waste streams so that we understand how much water they're actually taking up and what they're going to retain when we go to dispose of them. When washing MRF glass, one of the highest contributors to increased disposal costs is the loss of fines. Fine glass particles that were once usable material now end up in the disposal stream, along with small pieces of dirt and other debris which retain a significant amount of water. To determine the number of fines present in our sample, we wash the usable glass fraction. This allows us to then dry the material and determine how many fines were lost in this process. We then apply a correction factor that we determined experimentally from running our facility for how much water these fines retain, allowing us to determine our true disposal costs.
We complete a MRF glass assessment on the best recycling facilities determined through the market summary. That's the ones highlighted in green here. And we can see in this example, it's Jack's Recycling and Jacob's Recycling. So we go to our MRF glass, source number 1. We're looking at Jack's Recycling. And we're going to go through the contamination report that we generate when completing the testing. At the top, we have a summary of the final numbers from this report. And we get these numbers by starting with our initial sample mass from each of our 5-gallon buckets, as well as our unit mass from the material. This allows us to figure out how many tons of this MRF glass we're going to be able to get on the 18-wheelers coming in to the facility. In this example, it's 39.77 tons per tractor-trailer load. We do cap this at 27 tons for the purposes of the calculation because this is going to depend a lot on your state regulations. Next, we have the dry composition of the sample. So we have our ferrous metal, our non-ferrous metal, our dry paper and fluff. Remember, this is what we're removing with air, as well as our dry plastics and lightweights and our dry glass fraction. Next, we have our wet analysis of the sample. So our paper and fluff material is going to be removed with air, but our plastics and light waste we're going to have to wash, since this material will need to be removed to avoid air entrainment problems in the concrete. But it's going to retain some water, so we see how much it's going to take up during this process. We also wash our glass to determine the amount of fines that are lost in this process, as well as the amount of weight these fines are taking up. This brings us down to our net material and waste. So we know that from this sample, 84.57% of the sample is going to be usable glass that's converted into a glass SCM. And the important part here is that we have to normalize each one of these facilities to 1 ton of glass SCMs so that we can actually compare them side by side. And that means that we're going to need to take 1.183 tons of MRF glass from this facility to get 1 ton of glass SCMs. This allows us to determine the amount of waste material generated per 1 ton of glass SCMs so that we can properly represent our disposal cost. And in this example, it's 0.2129 tons or 425 pounds of waste generated from this MRF glass stream. This brings us to our cost analysis, where we have the revenue we're making per ton of glass SCM off the MRF glass, since we are taking in more MRF glass than glass SCMs we're producing because of that waste that we have to throw away. We then have an assessment on the inbound MRF glass logistics costs. In this example, we're doing it internally, so we have a good rate per hour on transporting this material. And then we have our disposal tipping fee and logistics. In this example, we say that it's $55 per ton, including logistics to transport this material and dispose of it. And finally, we have the source details. This is a high-level summary of that market research information, as well as the verified numbers from doing this contamination report and a photo of the glass generated at this facility. The third phase of the project is an analysis of the utility bill for where the facility is going to be located, allowing us to determine an actual electric cost for producing the material. We start with a bill from where the facility is going to be located or the closest point possible, and then we break that into our three main categories for how utility billing is broken out, which is supply charge. This is the amount of power that we're actually consuming. Our delivery charge, this is for the poles themselves and the infrastructure to get the power from the power plant, as well as our taxes and fees, which is largely going to depend on the state where this facility is located. Utility billing is very complex. They charge you in a lot of different ways for the power. So it's important for us to be able to build this as a calculator so we can punch in different numbers and see how this number is going to change as the operation scales up. A note I wanted to make on the supply charge is that these calculations are being run with the utility numbers that you're facing today. And that means that after about 1 year of operational history, we're going to be able to go out and contract for the supply of power for the facility. And that's going to result in a major decrease in the amount of money that we're spending on the actual electricity itself. This is something we did at our facility. Getting a third-party contractor for power was a huge game changer for us, and that's something we can help with once that facility has about 1 year of operations. And this brings us down to our average cost per kilowatt hour. This is the important number that we're getting from the utility bills. Next, we can plug this number into our electric calculator. So we see here each machine in the process, as well as how much power these machines actually consume. And we have very solid numbers for the consumption of these machines. We have multiple years of history tracking this. So we see here the total kilowatt hours consumed by the factory, and that gives us our electric cost per ton for this operation. The last piece of critical information that we get from our electrical analysis is the transformer size. At any facility where you operate this equipment, whether it be a building that exists or one that you're going to build, you typically need a power upgrade to support the equipment. The transformer to support this level of an operation would be at least 1500 kVA. In this instance, we're going to recommend a 2000 kVA transformer. One of the reasons that we recommend overshooting the transformer size, no matter what size facility you're putting in, is the utility company will sometimes pay for this upgrade. It really depends on a case-by-case basis, but there is a pretty good opportunity to reduce the cost of this. In the grand scheme of things, the transformer is a huge part of the project, but it's important that we understand what level of transformer we need. Now that we've completed the research project, we now have a facility summary with validated numbers. At the top here, we have our facility variables, and this is going to depend on how you actually want to go about operating this equipment. In this example, we use how we operate our facility today, which is where we run 6 days per week, and the ball mills run 24 hours per day during this operating time, and that's because of the software that these ball mills come with. The most important part of the research project is the unit cost. So we have each of our line items here, as well as each recycling facility that is supplying the operation, along with a weighted average of how these recycling facilities actually impact our bottom line based on the percentage of the inbound stream that they make up. We then combine that with our electric and wear parts, leaving us with a total unit cost of $78.69 per ton. We can compare this with the calculator we have online, and we see we're pretty close to that average number. And finally, we have our facility-wide pro forma, which is really to get a sense of what this operation looks like on an annual basis. And you can see here we have a glass SCM sale price of $148.09. This is largely based on your region and how you value the material, and so we'll work with you on that as we complete this part of the project. We then have our revenue line items, followed by our expenses, leaving us with an annual operating profit of $1.423 million every year.
Now that the project is complete, you have all information necessary to determine if glass SCM production is the right fit for your operations. The unit cost research project takes 4 weeks to complete and costs $28,000. This project is eligible for the R&D tax credit, and we provide all the information necessary to take full advantage of this. If you're uncertain about the market in your region, we offer the ability to take this project in sections, doing each phase one at a time. That way you don't have to purchase a full project. We highly recommend starting with phase 1, the market assessment, as soon as possible, as it is the best indicator of the viability of glass SCMs in your market. There are some really great glass markets out there that we have found over the years that would allow you to lock down the supply of MRF glass in your region, because in general, there is less MRF glass available than total concrete that can utilize the material, meaning if your facility is large enough, you could become the sole user and the supplier of glass SCMs in your area. If you have any questions about the research project or would like to begin, feel free to give me a call at my cell or schedule a call at the link below.